In the rolling farmland of Lancaster County, where horse-drawn buggies still travel quiet roads and old traditions refuse to disappear, one story has been whispered for generations. It's the story of a blacksmith named Eli Stoltz, a man who supposedly built something so simple, so practical, and so effective that it challenged the very idea of dependence on the electrical grid. According to local accounts, the year was 1938 when Eli climbed a modest 30-foot pole beside his workshop and bolted together a homemade wind turbine that cost only $120 to build. There were no corporate engineers, no million-dollar laboratories, and no government-funded research teams. Just a skilled craftsman, common materials, and the belief that a family should be able to create its own power. The remarkable part of the legend isn't that the machine worked, it's that people claimed it never truly stopped working. Long after decades had passed, long after technology had transformed the rest of America, stories continued to circulate that Eli's original design was still helping provide electricity for the family farm through careful repairs and practical maintenance. For many Americans, that sounds almost impossible. Every month, utility bills arrive with clockwork precision, demanding payment regardless of economic hardship or personal circumstance. The average household has become accustomed to treating electricity as a permanent expense of modern life. But throughout Amish communities across the United States, another philosophy has long existed. Instead of relying entirely on centralized infrastructure, families often seek practical local solutions tailored to their own needs, carefully balancing technology with tradition and community values. The result is a way of life that appears almost unimaginable to people raised in the age of endless monthly bills. And that is where the mystery begins. Hidden beneath old newspaper clippings and forgotten conversations lies the story of something known as USDA Bulletin 1156. According to persistent claims, the publication contained detailed plans showing ordinary Americans how to build affordable small-scale wind power systems using readily available materials. The story becomes even more intriguing from there. Supporters of the legend insist that hundreds of thousands of copies were distributed across rural America, reaching isolated farms where commercial electricity had never arrived. Families allegedly studied the diagrams, gathered materials, and experimented with building their own independent power sources. Then, according to the same story, something changed. As America's electrical infrastructure expanded and centralized utilities spread across the countryside, rumors emerged that the bulletin quietly disappeared from circulation. Copies became increasingly difficult to locate. References seemed to fade from public discussion, and whispers began suggesting that the information had been deliberately pushed aside in favor of a system that encouraged permanent dependence on utility companies. Was it simply an outdated publication that naturally vanished with changing technology? Was it replaced because better solutions became available? Or did something more deliberate happen behind the scenes? The answers remain the subject of debate, and separating documented history from local legend is far from simple. But one thing is certain. Stories like Eli Stoltz's continue to capture the imagination because they raise a timeless question. What if true energy independence was once far more accessible than most people have ever been led to believe? Before we explore the evidence, the historical records, and the forgotten documents that still survive today, we first have to understand the world in which this remarkable story was born. As the legend of Eli Stoltz spread through rural communities, America itself was undergoing one of the biggest infrastructure transformations in its history. Across the nation, new power lines stretched over fields, through forests, and into towns that had never before seen electric light. It was promoted as progress, and for millions of families it truly was. But another story unfolded in the background. Before giant transmission towers dominated the landscape, America had a thriving culture of mechanical independence. Blacksmiths, machinists, and local inventors built practical equipment that solved local problems. Small wind chargers appeared on isolated farms, providing electricity for batteries, lights, and radios long before the arrival of centralized service. Then came some of the biggest industrial giants of the era. Companies like General Electric and Westinghouse were rapidly expanding their influence as nationwide electrification accelerated. Massive investments flowed into centralized infrastructure, while government agencies worked to extend electrical service across rural America on an unprecedented scale. Critics would later argue that this partnership unintentionally, or deliberately, created a system that favored large utilities over independent household generation. According to this view, every new mile of copper wire represented not just technological progress, but a shift toward permanent dependence on centralized providers. Whether coincidence or calculated policy, the results were impossible to ignore. Throughout the 1930s, hundreds of American manufacturers produced small wind machines designed specifically for farms and remote properties. Their products were practical, affordable, and built for self-reliance. Rural families could purchase equipment, install it themselves, and reduce their dependence on outside suppliers. Among the best-known names was Jacobs Wind Electric, whose rugged machines became symbols of independent rural power. Across the country, countless smaller manufacturers competed with innovative designs, serving communities that larger corporations had little interest in reaching. But as federal electrification programs expanded and utility infrastructure spread across the nation, the market for household wind systems steadily declined. Demand shifted toward grid connections, investment followed centralized distribution, and many once successful manufacturers disappeared from the landscape altogether. By the middle of the century, an industry that had once flourished had largely faded from public memory. Yet the story doesn't end there. Decades later, during the energy crises of the 1970s, researchers once again examined whether small-scale wind generation could offer an economical alternative for homeowners. Government laboratories and research institutions explored new designs, performance data, and long-term operating costs in an attempt to identify practical solutions. Supporters of decentralized energy point to studies from that period which they claim demonstrated the economic advantages of smaller wind systems under certain conditions. They argue that, despite promising findings, public policy and investment increasingly focused on utility-scale projects rather than homeowner-owned generation. Instead of encouraging millions of families to produce electricity where they lived, subsidies and financial incentives largely flowed toward enormous wind farms and centralized energy developments connected directly to the national grid. The philosophy had quietly changed. Rather than owning the means of production, households would purchase electricity as an ongoing service, month after month, year after year, a permanent relationship between customer and provider. To critics, that wasn't merely an engineering decision, it was a policy choice with consequences that still shape everyday life. Supporters of the centralized model argue it created greater reliability, standardized service, and access to affordable electricity for millions of Americans who previously had none. Skeptics counter that the same policies discouraged innovation at the household level and made genuine energy independence increasingly difficult to achieve. Whatever side of the debate one accepts, the disappearance of America's once vibrant small wind industry raises an uncomfortable question. Did technology fail? Or did the system simply stop rewarding it? To answer that, we have to examine the forgotten designs themselves and the surprising engineering principles that allowed ordinary families to generate power with materials available almost anywhere. At first glance, it doesn't look like a machine that could power anything. There's no towering three-blade propeller stretching across the sky, no futuristic electronics, no complicated tracking motors or computerized control systems. Instead, the design resembles a giant strand of twisted DNA rising quietly above the ground, spinning with an almost hypnotic simplicity. But appearances can be deceiving. Unlike traditional horizontal axis wind turbines that must constantly face the wind, the so-called DNA-shaped vertical turbine is based on a helical design that accepts airflow from virtually every direction. There is no need for an elaborate yaw mechanism to rotate the machine into position, because the wind is always interacting with part of the structure. The concept combines ideas found in Darius and Savonia-style vertical axis turbines, blending lift and drag principles into a single rotating system. The result is a machine designed to start more easily in changing conditions while maintaining smooth, continuous rotation. That simplicity is one of its greatest attractions. Instead of relying on complex orientation systems and sophisticated electronics, the turbine's geometry does much of the work naturally. Fewer moving components can mean fewer maintenance points, making the concept especially appealing for isolated farms and off-grid applications. Supporters often argue that an 8-foot helical turbine can quietly harvest energy from winds that constantly shift direction throughout the day, eliminating one of the biggest challenges faced by conventional designs. Then comes the inevitable comparison. For decades, solar panels have been promoted as the face of residential renewable energy. Rows of gleaming modules covering rooftops have become symbols of sustainability and modern technology. But critics argue that solar comes with unavoidable limitations rooted in simple physics. No sunlight means no production. Every sunset instantly reduces output to zero. Heavy cloud cover lowers generation, while short winter days naturally provide fewer hours of available energy. Snow accumulation and seasonal weather can further reduce performance depending on location and maintenance. Wind follows a different pattern. Air continues moving long after darkness falls. Storm fronts arrive at midnight just as easily as noon. In many regions, nighttime winds become stronger as temperatures change, allowing properly placed turbines to continue generating electricity while solar systems remain completely inactive. Winter makes this contrast even more interesting. Cold air is denser than warm air, and denser air contains greater mass within the same volume. Because the energy available to a wind turbine depends heavily on air density as well as wind speed, colder conditions can increase the amount of extractable energy when sufficient wind is present. Ironically, the season that often challenges solar production can become one of the most productive periods for wind generation. Then there is the question of longevity. Around the world, stories exist of remarkably durable wind machines that have continued operating for decades with routine repairs and replacement of individual components. Properly maintained mechanical systems can often be serviced piece by piece rather than discarded entirely. Solar panels, by contrast, gradually lose efficiency over time through normal material degradation. Manufacturers typically provide long-term performance warranties spanning decades, but output slowly declines as the equipment ages, eventually requiring replacement to restore maximum production. To advocates of decentralized wind power, this represents more than an engineering debate. It represents two completely different philosophies. One emphasizes simple mechanical systems that can often be repaired and maintained for generations. The other relies on increasingly sophisticated manufactured technology designed around periodic replacement cycles. Neither approach is universally perfect. Geography, climate, maintenance requirements, and local economics all influence which technology performs best in a particular location. But the deeper question remains unchanged. If nature offers moving air every hour of every day, and even delivers denser, more energy-rich conditions during winter, why has public attention focused so overwhelmingly on one renewable technology, while the other has remained largely in the shadows? The answer may lie not only in engineering, but in economics, politics, and the incentives that shape entire industries. For decades, the biggest myth surrounding energy independence has been that it requires enormous wealth, advanced engineering, or access to technology beyond the reach of ordinary people. But among off-grid builders and rural tinkerers, another philosophy has always existed. They believe real independence begins with simple materials, practical knowledge, and the willingness to build something with your own hands. The list of required parts doesn't resemble the inventory of a high-tech laboratory. Instead, it looks more like the contents of a scrapyard or a local hardware store. An old treadmill motor that someone threw away, a length of galvanized steel pipe, a few pieces of PVC pipe, basic bearings, wiring, bolts, and a handful of common construction materials. According to longtime enthusiasts, many of these components can be salvaged or purchased secondhand for a fraction of the cost of commercial renewable energy systems. But experienced builders insist that the first weekend shouldn't involve cutting metal or assembling parts at all. It should be spent simply watching the wind. Using a handheld anemometer, they recommend measuring wind speed at different locations across the property throughout the day. A row of trees, a nearby barn, or even a neighboring house can create what engineers call a wind shadow, dramatically reducing airflow and making an otherwise perfect-looking location nearly useless for power generation. Understanding how the wind naturally moves across the land is considered the foundation of the entire project. Once the best location has been identified, attention shifts to creating a solid foundation. A galvanized steel pole is carefully positioned and secured in a reinforced concrete base designed to withstand years of changing weather and constant vibration. The strength of the structure matters just as much as the efficiency of the turbine itself, because no amount of engineering can compensate for an unstable support system. The following stage focuses on one of the most surprising pieces of the entire design, a discarded treadmill motor. While most people see broken exercise equipment headed for the landfill, resourceful builders see a permanent magnet motor that can potentially be repurposed into a compact electrical generator. With careful modification and proper wiring, something originally designed to spin a running belt may become the heart of a homemade energy system. Attention then turns to the blades, arguably the most recognizable part of the project. Large sections of PVC pipe are carefully measured, cut, heated, and shaped into smooth helical curves inspired by proven small wind concepts. The finished result resembles a twisting strand of DNA rather than the familiar airplane-style propellers most people associate with wind turbines. Every curve, every angle, and every adjustment is intended to improve balance and encourage smooth rotation from changing wind directions. Instead of relying on expensive electronic positioning systems, the design embraces mechanical simplicity. Basic bearings and standard pipe flanges allow movement with minimal complexity, reducing the number of components that can fail over time. To supporters of the concept, simplicity isn't a compromise, it's the entire point. Producing electricity is only part of the challenge. The next problem is storing it for moments when the wind slows or stops completely. Many traditional off-grid builders have historically relied on deep cycle battery banks, including repurposed golf cart batteries, to create substantial energy reserves capable of supplying power long after the blades have stopped spinning. The turbine harvests the energy, but the batteries make that energy useful around the clock. Ironically, many enthusiasts claim the greatest obstacle isn't engineering at all, it's regulation. Local zoning rules, height restrictions, setback requirements, and permitting processes can determine whether a homeowner is even allowed to install a small wind system. In some areas, backyard turbines are permitted under clearly defined conditions. while in others, the regulatory hurdles become so extensive that the project effectively ends before construction ever begins. Supporters of decentralized energy argue that these restrictions have gradually discouraged personal power generation while reinforcing dependence on centralized utilities. Others maintain that the rules exist for legitimate reasons involving safety, structural integrity, and neighborhood planning. The debate continues, but it leaves behind a question that has become increasingly difficult to ignore. If ordinary people truly have the ability to generate a meaningful portion of their own electricity using affordable materials and practical skills, why has that idea become so rare in the modern world? And if the knowledge still exists, perhaps the greatest challenge isn't learning how to build the machine at all, but rediscovering the confidence to believe that it can be built. In the end, this story isn't really about wind turbines, forgotten blueprints, or abandoned technologies. It's about a completely different way of looking at the world. For most of modern society, energy is treated as a commodity. It's something that arrives through a wire, measured by a meter, billed every month, and controlled by someone else. From the moment a family moves into a home, the assumption is already built into daily life. Electricity is something you buy, not something you produce. But in many Amish communities, the philosophy has always been different. Instead of organizing life around unlimited consumption, they organize it around what their own land and their own labor can reasonably provide. Every decision is measured against self-reliance, practicality, and long-term sustainability rather than convenience alone. The objective isn't to own the newest technology, it's to reduce dependence on systems that cannot be controlled by the individual. That philosophy becomes especially visible when nature is at its worst. During severe winter storms, polar vortices, and ice-covered roads, utility crews often struggle for days to restore damaged transmission lines across rural areas. Entire neighborhoods can sit in darkness, waiting for outside assistance before daily life can resume. Yet stories from self-sufficient farming communities often describe a different reality. Water pumps continue operating. Refrigeration remains available. Essential lighting still functions. Livestock can still be cared for. And daily routines continue with far less disruption because critical systems were designed around local resilience rather than complete dependence on distant infrastructure. For the families living that way, independence isn't a slogan, it's preparation. The financial argument is equally compelling to supporters of homemade energy systems. Every kilowatt hour generated personally is one that doesn't have to be purchased from a utility company. As electricity prices continue to rise in many regions, even modest reductions in monthly consumption can accumulate into significant long-term savings. Advocates often argue that carefully built low-cost systems assembled from salvaged materials can recover their initial investments surprisingly quickly, after which the energy they produce represents years of continued value. Of course, every location is different. Wind conditions vary, maintenance costs exist, and no single design guarantees identical results everywhere. But the larger principle remains remarkably simple. Reducing dependence on recurring expenses creates financial flexibility that compounds over time. And perhaps that's the real lesson hidden beneath all the legends and forgotten stories. Maybe the greatest wealth isn't measured by what you earn each month. Maybe it's measured by how little you're forced to depend on someone else. The story of Eli Stoltz, the mysterious government bulletin, and the forgotten wind machines may ultimately prove to be part history, part folklore, and part rural tradition. Researchers will continue debating the details. Historians will continue examining the records, and skeptics will continue asking difficult questions. But buried beneath every disagreement is an idea that refuses to disappear. Knowledge has value beyond profit. Practical experience outlives advertising campaigns, and the ability to provide for yourself has always been one of the most powerful forms of freedom a person can possess. Perhaps the most valuable discoveries are not always the newest inventions or the most expensive technologies. Sometimes they are old ideas, quietly passed from one generation to the next, forgotten by the wider world, simply because they offered ordinary people something that could never be sold on a monthly subscription. Whether this forgotten blueprint exists exactly as the legends claim is a question history must answer. But the search itself reminds us of something far more important. The tools for independence have always belonged to those willing to learn, willing to build, and willing to think for themselves. And sometimes the oldest knowledge is still the most powerful knowledge of all.